Okay.
Is it doing it? You can still go there. It's counting. Okay. Buffers have an incredible ability to absorb acid bases in order to keep the solution of pH from changing. This experiment will allow students to discover the buffer's activities and abilities to be unchanging when exposed to varying pH levels as a result of acid and base introduction. It will also require the use of titration techniques in order to define the concentration of acetic acid. Our hypothesis is the buffer will be able to maintain stability up to a certain level of acid and base introduction. The buffer will be able to maintain its neutrality but will eventually be overcome by the changing pH levels of the various solutions. Also, the buffer may be more effective in certain solutions. This experiment requires the use of household white vinegar, white paper, distilled water, scissors, well plate, hydrochloric acid, sodium hydroxide, and pH test strips. The first step is to place 2 milliliters of the white vinegar into the wells A1, A6, B1, and B6, then add 4 drops of NaOH to each well and then stir. Next, we will dilute the 6 milliliters of HCl to 0.1 HCl through the addition of distilled water. Do this per instruction to the NaOH as well. Lastly, for preparation, cut the test strips. Follow instructions as described in Part B and C and record observation and data. The test strips will be used per instructions in Part C of this lengthy experiment. Data and analysis. After adding 5 drops of Danielle into each well, the solutions all turn bright pink. After stirring the mixtures, the colors remain the same color. Then HCl is added to, why does that look like an eye? Is added to the first well, making the pink color disappear. Next, Na2EDTA is used in well number 2. After 8 drops, the solution is completely lacking in color. Conclusion: it is evident after performing this experiment that once a buffer is introduced to a solution that may be either highly acidic or basic, buffers quickly and effectively work to rebalance the solution. This is made clear by the color changes associated with the lack of and respectively the addition of a buffer solution. Practical applications. Lip gloss. Buffers are obviously found naturally in the human body, but they are also used in many areas of daily life. One example of this would be in shampoo. Shampoo contains buffers that balance out the alkalinity of soap that would otherwise cause chemical burns to the user's skin. Buffers are also used in diaper rash cream. This baby cream is designed with a pH that is a bit acidic, which allows the growth of bacteria, which could cause rash and infection in that area. Our objectives were to develop familiarity with the concepts and techniques of titration, to determine the concentration of an acetic acid solution, to determine that the acetic acid acetate ion pair can be used as a suitable buffer, to observe how well a buffer can withstand changes in pH when dilute and concentrated acids and bases are added to the buffer, to observe the ability in water to act as a buffer. A chemical buffer is a solution that resists change in pH when an acid or base is added to it. Buffers are capable of absorbing both strong acids and bases. They are important because many chemical reactions take place only within specifically narrow ranges of pH values. Unless a chemical buffer is present, the pH of a solution with a pH between 2 and 12 will be dramatically altered by the addition of only a small amount of acid or base. Recall that acids react with bases and not with other acids, while bases react with acids but do not with other bases. Only solutions containing both an acid and a base can resist the effect of both acids and bases. Thus, a chemical buffer solution must consist of a conjugate acid pair base and reasonable concentrations, and the pH of a specific buffer solution depends on the weak acid conjugate base pair it contains. Seconds. And what?
You should wrap.
I'm not
Wrap
wrapping.
like he does.
No, I'll leave the red one, David. Okay, you can turn it off.